Okay, guys, so lesson 12.1 is probability of events. And kind of the question that we're going to be answering throughout this lesson is how does describing events as mutually exclusive or independent affect how you find probabilities? So those two vocabularies, mutually exclusive and independent, are two different types of probabilities we're going to work with. And I know I say we're doing the basics today. I promise we're doing the basics. But we're going to look at those two vocabulary words and what it means, how it determines whether, how we find the probability. So let's look at our first situation here. You roll a standard number cube once. Let E represent the event of rolling an even number. Let T represent the event of rolling a 3 or a 5. And then what is the probability of rolling an even number or rolling a 3 or a 5? Thoughts? Disagree.
Oh, an even number.
Mm-hmm.
Yes.
How do we get that?
Well, there's 3 even and 3 odd numbers. And so if you're putting all 3 even and 2 of the odd, then there's one odd number.
Now, I'm going to use circles to demonstrate here. And again, this is a very easy problem. I'm knowing I'm making it a little bit more. I'm putting more into it than we really need because you guys have already said the right answer. I'm not disagreeing. But here's the deal. This is a very easy problem. Are they all this easy? No, we need to look at, okay, how do we get to that big answer? So E represents the event you roll an even number. What are the possibilities if you roll an even number?
50%.
But what are the specific possible outcomes?
6, 4, 7.
2, 4, 6? Okay. So probably, or possibility of rolling an even is a 2, a 4, a 6. And that was, they called that E. The other one was T, and T represents rolling a 3 or 5. So what are those options? 3 or 5. Are there any overlap there?
No.
No. In this case, 2, 4, 6, 3, 5, those don't overlap. And so officially, if I'm going to, make this look mathematically official, we're doing the probability of T. E was the first one, wasn't it? E or T. And to do that probability, then we are going to be adding. So probability of E or probability of T. What's the probability of E? So what's the probability of getting an even number?
50%.
Give me a fraction.
6.
Okay. And again, I'm not disagreeing with some of these other variations. Just not what I'm looking for. We'll talk about them. So 3, 6, because 2, 4, 6 out of 6 choices, right? Probability of 3 or a 5. That's how many choices? 2 out of 6. And then 3, 6 plus 2, 6 is?
5, 6.
5, 6. Now, is that any different than those of you that just counted it up on your hands and said 5 out of 6? No. And that is just as legitimate, okay? I'm not knocking it. I'm not saying it's wrong. I'm just saying this is the math behind it when you need the more complicated versions. Okay? So questions on what we did here. Because we're going to change it up. I'm going to change one word. Now we're asking what is the probability you roll an even number and a 3 or 5. Last time what was the word? Or. This time it's and. What does that one little word do? It's not the same. Really?
Is it too bad? Yeah.
No, it's still back up here. You roll a standard number cube once. So I'm going to draw my picture a little different this time.
You can't have the same.
Okay, so I'm going to draw my picture a little different this time. Again, what were my possible choices for E? And what were my possible choices for T? Are there any that I can put in that middle overlapping section? No. So what's the probability of an even number and a 3 or a 5? 0. Because where is the and section going to be? It's going to be in the middle. It's going to be that overlap. But none of these overlap. So in this case, it is just going to be a 0. And notice the difference is this was the probability of E and T. Okay? And so that is just going to be 0 out of 6, which is 0. Because in this particular scenario, I cannot get an even and a 3 or a 5. I don't know what scenario you could get an even and a 3 or a 5, unless it's 2 dice. Okay? And look at C then when you're ready. What is the probability that you do not roll an even number? What?
3-6.
3-6. Why?
Because there's 3 odds.
Okay. There's 3 odds, and those are my not even numbers, yes? Or can we look at it as, and this isn't the best example because it's split equally in half, but if 3 numbers are even, how can you find how many odds there are? Subtract from 6, yes? Okay. So this one is probability of it not being even, which is all the not evens. So 3 out of 6, which again is 1/2. Okay, guys. This situation we were just talking about were mutually exclusive events. When 2 events cannot happen at the same time, the events are mutually exclusive. So the probability of A or B is going to end up being the probability of A plus the probability of B, just like we did in that first example. They cannot happen at the same time. Now, a vocabulary word I want to throw in, just to mention, favorable outcomes. Okay? When we talk about probability, probability has often been defined over the years as the number of favorable outcomes over the number of total possible outcomes. Well, favorable, what does that mean? An outcome that is being tested or observed, but not necessarily a desirable result. Indicating favorable is just whatever you're being asked to find the probability of, yes? So if you're being asked to find the probability that you get sick, what is the favorable outcome? You getting sick. Okay? So not that getting sick is favorable, but that's the favorable outcome because that's what was asked here. So just a little comment about that vocabulary. Let's try the next example. A box contains 100 balls. 30 of the balls are purple and 10 are orange. If you select one of the balls at random, what is the probability of each of the following events? So the first one asks the probability if the ball is purple or orange. 40%? Can we go for that answer? Okay. Officially, if I get more official than I know you guys want me to, this is what? Probability of purple plus probability of orange. What's the probability of getting a purple ball? 30 out of 100. Probability of getting an orange ball? 10 out of 100. 30 out of 100 plus 10 out of 100 is going to be 40 out of 100. Now, types of answers today. Well, I can tell you Savas will not, absolutely not accept the answer I've written up there currently. Because it's not reduced. So what is the simplified fraction here?
4/10.
Savas would count 4/10 as a fraction wrong.
2/5.
Okay, 4/10 is a good step. That's where my brain goes to. But 4/10 reduces to 2/5. What is this as a decimal?
0.4.
Remember, it was 4/10, so 0.4. And what is this as a percent?
40%.
Move the decimal 2 right, and it is 40%. Now, depending on the problem, any of these three answers might be what they're looking for. Okay? There are some answers or some problems in homework that specifically ask for a percent. Okay, so I think you'll only get percent when it's specifically asked. There are some problems, I think, that specifically ask for either a fraction or decimal. Watch what the directions say. Fractions will say reduced. I know there was one I was practicing, I was checking to see how to make sure my math was right this morning, and it didn't say fraction or decimal. So I tried it once with a fraction and once with a decimal, and both times it was good to me. So there might be some where you can enter fraction or decimal. Just a thought. I don't know. I was kind of surprised when I earned it one time as a fraction, one time as a decimal, and both times it liked it. So anyways, any three of those answers would be okay then, depending on what they ask for. Okay, have you thought about B? The ball is not purple and not orange.
60.
How'd you get that so quickly?
I subtracted 100 by 40.
Okay. Easiest version, it was 40%, right?
Yeah.
So if 40% is in favor of purple or orange ball, then the other 60%, we can think of it in terms of, if you think of this was, excuse me, 100% being 100 over 100 minus the 40 over 100. And the idea that 100 over 100 is 1. And I say that because, so what is the probability? If the probability is 100% there, that is equivalent to 1, right? So the idea is if we know 40 out of 100 is probably of purple or orange, subtracting it from 100 over 100. Okay, so however you're going to get there, it's going to be 60 over 100. What is that as a simplified fraction? 6 over 10 reduces to 3 over 5. What is this as a decimal? Then I'm going to go back to the 6 over 10, which is 6/10. And as a percent, we already said it was 60%. Again, all those are equivalent, right? Old news, right? I don't think I'm teaching anything too fancy right now. I feel like this is stuff you've done over the years. Maybe I'm boring you. That's okay. Don't complain, right? Okay, a little bit more vocabulary or just a couple of concepts here. What we were just talking about, probability of mutually exclusive events. If A and B are mutually exclusive, probability of A or B, you're going to add them. That's what we've been doing. We had an example up top, probability of A and B when they're mutually exclusive. Well, that's the example we had up in the middle here, where it was 0. There was no overlap, so it was 0. And then a vocabulary word real quick before we move on. With the last problem we just did, we just talked about the complement. The complement of an event is a set of all outcomes in a sample space that are not included in the event. So we asked for not purple and orange. That is the complement of purple and orange. Easiest thing to do is to subtract from 1 there. Okay? Not saying it's the only way, just saying it's the easiest way. Okay, ready to do some more probability? Turn the page. A A student-made target includes two overlapping squares. Assume that a sticky ball is thrown at the target is equally likely to land anywhere on the target. What is the probability that the ball lands inside one or both of the squares? So let me make sure you understand, first of all, the target is the whole big rectangle. Okay? So the whole big gray thing, if you look up at mine in the color one, probability is, or the target is the whole big thing with two overlapping squares in the middle. We're being asked what's the probability the ball lands inside of one or both of the squares. So, thoughts on how we're going to do this? Dane?
You're going to find the area of both the squares and then the square inside of it, and then you're going to find the area of the entire thing, and then put the area of the inside squares over, in a fraction over the outside square.
Okay, for the most part. Might be one part in there we need to tweak, I'm not sure yet, but okay. General idea, though, is we have to talk area, don't we?
Yeah.
In this situation, we're definitely doing probability by area. So what are some areas you can tell me here? Let's get our areas written down. Because there are several that are pretty easy to tell me. What's one, Lily? What?
I just forgot. The squares is 500.
Which,
Like the yellow square, because it's 10 times 10 times 5.
no. So the yellow square is 10 by 10. The 5 is indicating overlap and overlap. So the whole yellow square is just 10 by 10, which is 100. And I'm going to call this square A. So square A is 10 by 10, which is 100 square centimeters. And I'm just gathering my information right now. What else do we know?
Blue. B is the exact same.
Okay. B is also a 10 by 10 square. So B is going to have an area of 100 square centimeters. What else?
B is 5 by 5, so it's going to be 25.
Okay, the A and B overlap, where the blue and yellow overlap, what looks green, is going to be 5 by 5. And I'm going to call that A and B. So that 5 by 5 is going to be 25 square centimeters. There's one more area we need, and that is what?
It's the outside area, which is 100.
Okay, the big entire area, right? Officially, it's the whole area of the target. I've just been writing entire area today. But that entire area is 20 by 60, which is 1,200 square centimeters. Okay. So, we have all the areas we need. What are we thinking here?
To find the P of A, you put 100 over 1,200. Probabilities.
Yes. I was going to go about it. I'm just trying to decide how I want to go about it.
Okay.
I've been doing it slightly different, but okay. So one option, you're saying, okay, to find the area of A, it's going to be 100 out of, or not the area, the probability of A, 100 out of 1,200, right? And then you'd also have to do B, and we'd also have to talk about A and B. What I've been doing, and it's not a right versus wrong thing, okay? What I've been doing is just finding, okay, what is the area of A or B? I haven't been looking at the probability. But if we just find the area of this blue and yellow piece, in other words,
Oh, the whole
Okay, that's what I was doing. And again, multiple different ways we could do this, right? Maybe I'm not doing it the easiest way, but. So how are we going to find, if we're trying to find the area of this piece right here, how are we going to do that? What are we doing? Go ahead, Dane.
Just add them all together.
Not exactly. What do you think?
Add them together and then subtract 25.
Mm-hmm. Because what's happening?
They're overlapping.
The yellow is 100, the blue is 100, but in that little green piece in the middle, they're both overlapping there, yes? So that overlapping piece is being counted twice. So what I like to do is, I agree with you guys, 100 plus 100 minus the 25. Now I will say the book also showed doing just the yellow, which is 75, plus just the blue, which is 75, and then the green, which is 25. I didn't like that one as much. I thought it was easier to see the 100s. So if we do, that is not the color I wanted. 100 plus 100 and then minus 25. What is that math? Okay, that is 175 square centimeters. Okay, so 175 square centimeters is the area of these overlapping squares. What's the probability we're going to land in these overlapping squares?
25.
I don't know.
You take the entire area divided by that little square.
Other way around, but yes. Okay, so in other words, since we're doing probability of A or B, it's going to be the 175 divided by the 1200. Okay, so in order to do the probability of A or B, is what I'm calling it, 175 over 1200. I need a better form of that though. What?
Oh wait, did you want to simplify?
Yeah, that's, yeah.
Okay, 7 over 48.
Okay. 25s, right? If you divide by 25s, it is 7 over 48. Now, if I'm guessing correctly, if I'm remembering correctly, this type of problem is going to be the type of problem that's going to ask you to express your answer as a percent rounded to the nearest whole number, I believe. Or whole percent. If we're doing a percent, what do we have to do? First of all, divide 7 by 48 and get that decimal. What is that decimal?
10.1453.
Okay. What is that as a percent?
14.6%.
Okay. Well, 14.5, 14.6% rounded to the nearest whole percent.
So it's 15.
15%, right? Basically, this 5 tells the 4 to go up, and it becomes 15%. Trust me, I know. My brain wants to give a tenth to a 1 decimal place too, but
Chemistry.
the homework was giving whole numbers. So when I do something like that, I'm trying to, okay, what are you going to expect to possibly see in homework? Whole numbers, right? Okay, questions on this one? Probably the hardest one you're going to see today here. Not horribly difficult, but we have to think a little bit, don't we? And you've seen stuff like this before. I know you have. So, okay, let's try the other example like it. A video game screen is a rectangle with dimensions 34 centimeters and 20 centimeters. A starship on the screen is made of 2 circles with radius 6 centimeters and overlapping area of 20 square centimeters. A black hole appears randomly on the screen. What is the probability that it appears within the starship? Disclaimer, I did not write the problem. It came from the book. So what are we thinking? Do we need the picture?
There's a picture.
We can draw a picture.
Oh,
I mean, it's one of those things. Do we have to draw the picture? No. Can we draw the picture?
Yeah.
We can. Okay. It's not, I could definitely do this without drawing the picture, but if you want a picture to kind of visualize. There's my video game screen. What do we know about my video game screen? 34 centimeters, 20 centimeters. And what's on this video screen? Our starship, which is made of 2 circles, radius 6, overlapping. So, can you visualize? I have no clue how that forms a starship, but we're going with what it says here. Okay? And the thing is, the circles are the same size, right? We know the overlapping piece, I think I made that too small to really write in there, is the 20 square centimeters. And we know each circle has a radius of 6. Okay. Again, we're going to be talking in terms of area, correct? What areas can you tell me?
The entire area.
Okay. The entire area of the screen, that is 34 by 20. Well, 34 times 20 is 680. So the entire area of the screen is going to be 680 square centimeters. What'd you say? Not circumference. What do we need of the circle?
radius, diameter,
We have the radius. What are we trying to find on the circle?
area.
The area.
Okay.
Okay. This is where my classes have been getting quieter. Area of a circle. Area formula for a circle. What?
2 pi r squared.
That would be a combination of circumference and area.
Oh,
So one circle is just
2 pi.
2 pi.
It's just pi r squared.
pi r squared.
Oh.
As I said, this has been a struggle today. And this is where I'm going to say, you guys are high schoolers. Older high schoolers at that, you should know area of a circle. So I'm not doing the whole starship right now, but one circle is pi times
R squared.
6 squared, right? What is 6 squared?
36.
So I'm actually just going to write this as 36 pi. Now, could you write the decimal? You can. Just be careful about rounding it too soon, which is why I just like writing 36 pi. Then I don't have to write all those crazy decimal places. Let's see. And besides the circle, the other thing we need to know that they've already told us is the overlap, and the overlap is 20 square centimeters, right? Okay. How are we going to do this? What do we know about this starship? What do you know about the area of the starship?
There's 236 pies.
There's 236 pies.
Well, you add that.
What?
I don't know.
There's 236 pies, so 36 pi plus 36 pi is circle plus circle
72 pi.
is going to be 72 pi. What else do we have to do, though, for the starship? These circles were what? They're overlapping, so we have to subtract 20. Okay. And so this means the area of the starship,
52 pi.
not exactly.
What?
36 was 36, 72 pi minus 20. Think like terms. They're not like terms.
Oh,
Now, if you are not caring for my 72 pi, you can turn it into a decimal and give me one big decimal answer here.
I'm good.
But in all honesty, I can enter this in the calculator here in a moment just as easily as I can the decimal. Okay, either way, you're going to have to do the math. So, if you want the decimal, it is what? 206 point. I have 1946711, something like that. Now, realize, what is this? This isn't my probability. This is just the...
Pi.
What is this we found? The area of the starship.
I don't think you like the answer.
How do I do the probability of the starship? Because what is this? A black hole randomly appears on the screen. What's the probability that it appears within the starship, right? So we need to find the probability it appears within the starship. How are we going to do that? Okay, she says put it over 680, it being the 206 number. Or, honestly, how I have it written in my notes is 72 pi minus 20. Now, grab the calculators, do the math.
That's the big number.
When you do the math, I would do 72 pi minus 20. So 72 times pi minus 20. Hit equals. Get that number, which is going to be that 206 number. Or if you already got that 206 number, you already have it on your calculator, right? And then divide by 680. You're getting a fun number, I know. Syntax error is not the fun number I was looking for. Okay. What are we getting in here?
0.303227.
I'm good. Okay. 0.30322, I don't know. If this problem is like the last one, it asks us to express this as a percent, rounded to the nearest whole percent.
30.
Right? It would, if you move the decimal, it's 30.322%,
30.
which then becomes 30% when rounded appropriately. Okay. Okay. Those are probably the hardest, well, definitely today because we're almost out of time. But you've done probability with area. I know that's not brand new. So you've done that. It's just a matter of finding those areas, remembering all those area formulas. Yes, you should know area of a circle at this point in your life. Okay. Now, as we, the concept there before we briefly talk about the last one, what we were talking about there a little bit was non-mutually exclusive events. The idea that if they are not mutually exclusive, okay, that means they could happen at the same time. The overlapping area was our example just then. And so for not mutually exclusive events, you're adding the probability of A, adding the probability of B, and then subtracting off the overlap. Now, we're not really going to answer many of these questions. We'll save these for tomorrow. But I want you to consider this situation because we're going to do a little bit of prep work for this section. A pair of dice is rolled. Consider each probability. Now, what do I mean a pair of dice is rolled?
2.
2 dice, each labeled 1 through 6. Okay. Probability of getting a sum of 5.
That you get 3.
So I see some finger counting going on, right?
You could throw one of the dice and just roll.
What kind of options are we getting? 4, 1, 3, 2, 2, 3, 1, 4. Now, and here's the deal. What are we all doing? We're all kind of struggling like, okay, wait, what are my options and all that. Okay, so my suggestion, so you can be familiar with it, and this is what I'm going to do here. Before we go through and start answering these questions, I'm going to draw us out what our sample space is going to be, what our possible outcomes are going to be. So we're not here all trying to count on fingers and figure out which ones there are. Okay? Because I'll be honest, sum of 5, that was probably one of the easier versions of, when we're trying to figure this out. So I'm going to set up a chart over here. At the top of the chart, let's see, how have I been doing this? At the top of the chart, I'm going to have the second die, and I'm going to put the first die along the left. What are the options on that second die? And that is a 1, 2, 3, 4, 5, or 6. On the first die, what are my options? 1, 2, 3, 4, 5, or 6. And this is the options on the first die.
By first,
Okay? Now, how do we fill in this chart so we have our visual? So if you roll the first die, you get a 1. The second die, you get a 1. So the first pair is 1, 1.
Oh, that's not what
Or first die, second die, a 1, then a 2. 1, then a 3. 1, 4. 1, 5. 1, 6. Continue. The second row, we're going to have
a 2 and a 1,
2, 1.
a 2 and a 2,
Continue it in.
The instructions for your afternoon announcement.
2 and a 5.
All members of the golf team practice has been canceled for this evening. Softball players, your game has been canceled. Baseball players, your game has been rescheduled to tomorrow. And members of the high
3 and a
school
5.
practice, your meet has, baseball, your game has been rescheduled to Thursday, and track, your meet has been rescheduled to tomorrow. 6th, 7th, and 8th graders, don't
4
forget I learned
and a
something
5.
next week, Monday and Tuesday, April 24th and 25th for math,
5
and
and 1,
Wednesday and Thursday,
5
April
and
26th and
5
27th
and 3,
for ELA.
5.
You must have headphones for
5
the
and
ELA.
5.
Be sure to eat good breakfast and have a stress-free morning.
5 and
Testing
6.
will be in the high school gym. Corteva AgriScience is looking for students interested in summer employment. You must be 14 years old by
6
July
and
1st.
5.
Pay starts at $15 an hour. Use your student email for additional details and
We will use this
online
chart tomorrow.
application link.
I
There
get
are
it.
also hard copies